Algebra 2, Chapter 8.2, Exercises 1 through 12. In this section, we're going to be doing the finding of rational zeros of each polynomial function, and then write each function in factored form. Now, the first thing I'm going to do is use what's called the rational zeros theorem. And rational zeros, or rational roots theorem, is a technique where you look at the possibilities of rational zeros, and what you do is you take the factors and I'm going to say plus or minus the factors of a constant term over factors of coefficient of first term. Coefficient of first term. And in this instance, we're going to have the final term is 8, so we have plus or minus the factors of 8, which are 1, 2, 4, and 8 over the factors of the coefficient of the first term. Well, we just have x cubed, so we have 1. And so our potential zeros, potential rational zeros, RAT plus V zeros are going to be as follows. We have plus or minus 1, comma, plus or minus 2, plus or minus 4, and finally plus or minus 8. And what we're going to do is use synthetic division to check these, and what I recommend doing most of the time is using the smaller numbers first. And so the first zero we're going to check out is 1. So I'm just going to put down here check x equals 1 as a 0. And to do that, using the synthetic division, I'm going to put that over here. And let's do that. So check 1, we put 1 over here to the left of the bracket, and then the coefficients of the what we're going to divide by, x cubed minus 1x squared minus 10x and minus 8. So we bring down the 1, and we have 1. 1 times 1 is 1, 0. 1 times 0, 0, negative 10. And we have 1 times negative 10 is negative 10. So negative 18. So we have a remainder. So we'll say not 0 because remainder does not equal 0. Because remainder not equal 0. Okay? Next, we're going to try negative 1. So I'm going to say check x equals negative 1. And to do that, we'll go ahead and put in negative 1, 1, negative 1, negative 10, negative 8. Okay, so bring down this 1. 1 times 1, negative 1 times 1, negative 1. negative 2. Negative 1 times negative 2 is 2. Add these together, negative 10 plus 2 is negative 8. Negative 8 times negative 1 is 8. So we have 0. So we have, yes. So if we have x equals negative 1, we have to find the factor. So we put x is equal to negative 1. And to find the factor, we have to add negative 1. Add 1, excuse me. So we add 1 to both sides of the equation. So we have 0 equals x plus 1. And so factoring this out, I'm going to write this up here. We found x plus 1. I'm going to take this 0 equals x plus 1. Bring it up over here. So we put quantity x plus 1. That's one of our factors. And left over we have, this is 1x squared minus 2x minus 8. Well, factoring x squared minus 2x minus 8, we have the factors of x squared are x and x. To get a negative 8, we have to have a minus and plus. And then, what are the factors of negative 8 that add up to negative 2? Well, I think they're going to be x minus 4 times x plus 2, because negative 4x, that's going to be negative 2, 2 times x. So this, these are our remaining factors. I'm going to bring right up here. So we put times quantity, x minus 4 times quantity x plus 2. Okay. Did you notice the amount of room I was using here? On the sheet, you might spill over into 2. This is one of these exercises for the, if you have my standard worksheet, you might want to have extra paper to help do the multiple synthetic divisions. That could be quite helpful to you. Let's go on to do the next order problem, which is 3. We have j of x equals 2x cubed minus x squared minus 13x minus 6. And so using our rational roots theorem, we're going to have plus or minus factors of 6, which could be plus or minus 1, comma 2, comma 3, comma 6, over the factors of our coefficient, which are going to be 1, comma 2. And now, to find our list of factors, potential list of factors, we have 1 over 1, or plus or minus 1 over 1, and then 1 over 2, so that's going to be plus or minus 1/2. And then we have 2 over 1, which is 2. Next we have 2 over 2, well, we already have 1, so that already checks out. Then comma, plus or minus 3. And then we have 3 over 2. So we're just going down the list here, plus or minus 3 over 2. And then we have plus or minus 6 over 1. And then we have plus or minus 6 over 2, but we already have represented that in 3. So we have a list of 12 possible rational zeros. only 3 of which can be actual zeros because we have a third power. So let's go ahead and work this out. And again, I suggest using, we're going to check one at a time. We're going to check 1. And I just find, unless you have additional information, just go down the list. So here we have, we're going to use 1. So here we have 1, and then we have 2x cubed negative 1x squared minus 13x, and then we have minus 6. We bring this down, so we have 2. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 1 is 1. Negative 13 plus 1 is negative 12. 1 times negative 12 is negative 12, and we have negative 18. So we'll say not a 0. Next, we're going to try x equals, I'll put this down to check x equals negative 1. So we're going to go ahead and put in our negative 1 on the outside. And inside we put in, like the last time, 2, negative 1, negative 13, negative 6. Bring down the 2. We have 2 here. Negative 1 times 2 is negative 2. Add negative 1 and negative 2 together, we get negative 3. Negative 1 times negative 3 is 3. Negative 13 plus 3 is negative 10. Negative 1 times negative 10 is 10. And we get 4 left over here. So we will say also not a 0. Okay, we're going to continue on down the list. Check, we're going to check x equals 2. So we go here. So we're going to check 2 on the outside, and inside we have 2, negative 1, negative 13, negative 6. Bringing down the 2. We have 2 times 2, 4. Negative 1 plus 4 is 3. 2 times 3 is 6. Negative 13 plus 6 is negative 7. 2 times negative 7 is negative 14. And so we get negative 20. So we make the same conclusion for this one, not a 0. Now, what I hope is that you're able to see, while this is a bit tedious and that we're having to go through some paces here, rigor-wise, it shouldn't be too hard. Next, we're going to check x equals negative 2. Now, we could have checked 1/2 also, but the arithmetic for that one is a little more complicated. So we put negative 2 here, and then 2, negative 1, negative 13, negative 6. And so we bring down this 2, negative 1 times 2, negative 2 times 2 is negative 4. Negative 1 plus negative 4 is negative 5. Negative 1 times negative 5 is, or negative 2 times negative 5 is 10. Negative 13 plus 10 is negative 3. Negative 2 times negative 3 is 6. And we have 0. So x equals negative 2 is a 0. So in this equation here, x equals -2. If we add 2 to both sides of the equation, we have x plus 2 is equal to 0. And so we have our one of the factors here, which I'm going to just put up here. And I'm going to put in equals, I have x plus 2. And then we have left over 2x squared minus 5x minus 3. And how do we factor that? Well, you can go ahead and put the parentheses like this and just kind of fiddle around. One thing I've done in my classes is shown something called the x method. So you have a equals 2, b equals -5, and c is equal to -3. And so what we do is we make an x here, and we say c goes on top, b goes on the bottom. Well, a times c is 2 times -3, which is -6. And then b is -5. So what two numbers will, when multiplied together, equal -6, but when added together equal -5? Well, how about -6 and 1? And then, so that works out. We add them together, we get -5, multiply them together equal -6. Now we divide by a, which is 2, and simplify. Well, -6 over 2 is going to be -3. So down here, I'm going to put x minus 3, and then x plus 1/2. And then we use the bottoms up method here. So we have, for factors x minus 3 times quantity, we take that 2 times x. So we have 2x plus 1. And those are the other factors. So I'm going to take these other factors here and bring them up here, drawing a bunch of arrows. It's kind of a complicated looking thing here. Okay, then we have quantity x minus 3 times quantity 2x plus 1. And that will be our answer. And of course, that's going to be j of x. So that's our answer. I want to make sure I had the notation right on number 1. Did I have it right? Yeah, I did. I wrote it to the right here. That's okay. Okay, next, number 5. And again, you can I invite you to stop at any time just to kind of check things out and see if you can work it out, and then play ahead to see if you got it right. Okay, this one here, our potential rational zeros are going to be plus or minus factors of the last term. And this is going to be similar to problem number 1. So we have plus or minus 1, comma 2, comma 4, comma 8. And then that's going to be all over 1. So our potential rational zeros are going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And just working that out, we're going to check 1. I would say check x equals 1 as potential 0. So we put 1 here. So 1 goes here. And then 1x cubed negative 5x squared plus 2x plus 8. And just work that out. We bring down the 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. Add these together. We have 2 plus negative 4 is negative 2. And we have 1 times negative 2 is negative 2, and we get 6. So we will conclude not a 0. And then we're going to check x equals negative 1. And so we put negative 1 on the outside here. So negative 1. So we put the same thing, 1, negative 5, 2, 8. Bring down the 1. We have 1 here. Negative 1 times 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 6 times negative 1 is 6. 2 plus 6 is 8. Negative 1 times 8 is negative 8. So we have a 0. So we have is a 0. So we have x equals negative 1. That is a 0. And if we add 1, we have x plus 1 is equal to 0. So this is one of our factors. So we're going to bring this up here. So I'm going to put equals. We have quantity x plus 1. And now what do we have left here? We have x squared minus 6x plus 8. And that's going to be equal to factors of x squared are x and x. Now in this case, we have a negative middle term, but a positive final term, or constant term. So we have to have a negative times a negative. So what do these two numbers have to be? Well, we have x minus 2 times x minus 4. That's going to make this thing work out. So we take these other determined factors by factoring a quadratic trinomial, put this right over here next to it. So we have up here quantity x minus 2 times quantity x minus 4. Okay, let me get that erased here. Pen is going a little glitchy on me. All right, so that'll be it. Okay, h of x equals that. That's our factored form, and that's equal to h of x. Next, on our problem 7. Okay, we have, in this case, we just have our potential rational zeros are going to be plus or minus 1 over 1, which equals plus or minus 1. So I hope that makes things easier for us, but we're going to test out, we're going to check x equals 1. And so to do that, I'm going to put 1 out here, and then 1x cubed minus 1x squared minus 1x plus 1. Bring down the 1. 1 times 1, 1. Negative 1 plus 1 is 0. 1 times 0, 0. Negative 1 plus 0, negative 1. 1 times negative 1 is negative 1, 0. So x equals 1 is a factor. So for that, we're going to put down x equals 1, and subtracting 1, we have x minus 1. X minus 1 is equal to 0. So this is going to be our first factor we insert. So x minus 1. And left over we have x squared minus 1. Well, this is a difference of squares. So what we have is we can take the square root of x squared, which is x and x, and then we have plus or minus the square root of 1, our second term, which is 1. So these will be our other two terms. So we put these others up here as quantity x plus 1 times quantity x minus 1. And that's going to be it for that one. Okay, number 9. Well, in this case, our potential rational zeros are going to be plus or minus factors of 27, which are going to be plus or minus 1, comma 3, or plus or minus 3. And plus or minus 9 over 1. So that's going to be plus or minus 1, comma plus or minus 3, comma plus or minus 9. And I forgot one more, didn't I? How about plus or minus 27? So those are that's our list of potential rational zeros. Well, first thing we're going to do is check x equals 1. Well, so we put 1 out here, and then 1x cubed minus 9 x squared plus 27x minus 27. So we have, bring down 1. 1 times 1 is 1. Negative 9 plus 1 is negative 8. 1 times negative 8 is negative 8. 27 minus 8 is going to be 19, I think. Yeah, 19. And then 1 times 19 is 19. And then we get negative 27 plus 19. That's going to be negative 8. So not a 0. Next, we're going to check x equals negative 2. All right, I said negative 2. I meant to say negative 1. So we put negative 1 here. So negative 1. And we have 1, negative 9, 27, and negative 27. So we bring down the 1. So 1, negative 1 times 1 is negative 1. Negative 9 plus negative 1 is negative 10. Negative 1 times negative 10 is 10. Add these together, we get 37. And negative 1 times 37 is negative 37. And what is that going to be? Negative 64, not a 0. So not a 0. Next, we're going to check 3, x equals 3. Again, shouldn't be terribly difficult. It's just taking the time on it. So we put 3 here. And on the inside we put 1, -9, 27, and -27. And so we have let's bring down the 1. So that's going to give us 1 here. 3 times 1 is going to be 3. -9 plus 3 is -6. 3 times -6 is -18. 27 minus 18 is 9. 3 times 9 is 27. So we have 0. So we have x equals 3 is a factor. So we have, if we put x equals 3 and solve for 0 and subtract 3 from both sides, we have x minus 3 is equal to 0. And so this becomes our factor, the first one that we examined. So we'll come up here and put quantity x minus 3. And then left over we have x squared minus 6x plus 9. And that's going to be equal to, we have x times x. We have a middle term of negative, and the constant term is positive. So we have to have a negative times a negative. We're going to have -3 times -3. So those are going to be our other two factors. So we bring these up here. We have quantity x minus 3 times quantity x minus 3. And that is going to be our factored form. A triple 0 if x equals 3. Okay, the next one I'm going to do in this exercise set is this one here. We have plus or minus the factors of 210 over the factors of 1. So I'm just going to go ahead and work this out. Plus or minus 210, comma, we can cut this in half, right? 210 in half is going to be 105. A lot of factors here. If we divide by 3, we have plus or minus 70, plus or minus 30, plus or minus, we can divide by 4, plus or minus 45. If we divide by 10, we'll have plus or minus 21. If we divide by 21, we'd have plus or minus 10. We would have this 30 we can divide by 2, so that could be plus or minus 15. They already have plus or minus 35. Yeah, plus or minus 35. Because that's 70 divided by 2. We could have plus or minus 6, plus or minus 7, plus or minus 5, plus or minus 3, plus or minus 2, and plus or minus 1. And is that all of them? I don't know. That's a bunch. Now we can go through 1 and 2 and 3. I am going to, in the interest of time, I'm going to let x equal 5. This is already an enormously long video lesson. So yes, I have a little insight here. I'm going to put 5 out here. And we have 1x cubed minus 6x squared minus 37x and 210 right here. And we bring down the 1. We have 1 down here. 5 times 1 is plus or minus 14, plus or minus 42. My gosh. I guess if you put 360 as a final term, you might have more. Anyway, 5 times 1 is 5. Negative 6 plus 5 is negative 1. 5 times negative 1 is negative 5. And negative 37 plus negative 5 is going to be negative 42. 5 times negative 42 is negative 210. So we have 0. So we have x equals 5 is a factor, or is a 0. So we have x is equal to 5, and to find our factor, we divide by, subtract 5 from both sides. We have x minus 5 is equal to 0. So I'm going to put up here above, we'll have quantity x minus 5, and then I want to make room for my other factors. Okay, then we have x squared minus x minus 42. What is that going to be equal to? Well, we're looking for, definitely we have x and x, and we have negative 42, and have negative numbers, a constant term, we have a minus times a plus. And to get this negative x, what are the factors of 42? Well, how about 6 and 7? And we have negative x, so we should have x minus 7 here, and x plus 6. And if we remultiply these together, we're going to get x squared minus x minus 42. And so we take these other two factors, move them up here, and we have quantity x minus 7 times quantity x plus 6. And I invite the viewer to go over these even number problems. I hope this has been helpful to you. Good luck, and thanks for viewing.